Hey folks, here we go. It's our last test, other than the final. We have plenty to review for the final next week, but here we go. Chapter 9 and 11 test review, quick review and recap of what we've learned so far, along with vocabulary review and toolkit fill-in, plus some tips for the test. FYI, this one might be a little bit longer than normal. There's a lot of formulas and stuff to go through, so at any time, I'm going to try and keep it short, so if you need to pause and write down a formula, you certainly can. But let's get started. The first thing that you want to actually look back for is your salmon colored toolkit, kind of like this color-ish, maybe like a blend of these two. That's better. This is the Chapter 8 toolkit, and one of the things that you're going to need from that toolkit is you got to know how to find the area of a regular polygon. You have to know how to find the area of a regular pentagon or a regular octagon, okay, or whatever. They're not always hexagons, triangles, and rectangles. So we're going to be testing you on that. And what you can do is you can always make a right triangle out of that isosceles triangle. And for an octagon, there'd be 8 of these, one to each vertex. So there'd be 8 of those, and I can find this angle by doing something like 360 divided by 8, which would be 45. And then I can divide that in half, 22.5 degrees. Okay, so you got to know how to use that, how to use tangents, sine, cosine, whatever, to figure out what your height is. Once you know your height, you can use this formula, okay? It would be the base times the height divided by 2, and then times n, the number of triangles. So you need to write this down in your toolkit. You certainly can as a reminder, but you have to know how to find the area for this test. That's critical. Also from the Chapter 8 toolkit, circles. There are some arc length questions on here. Okay? How do you find an arc length? How do you find a sector area? Okay, so we got to know that. And we did some of that with as we were exploring our cones and our cylinders and our spheres. So you got to know how to find that. You got to know how to find the area of a circle. Cylinders and cones use that. Make sure you remember that the diameter is 2 times the radius. A lot of times in our problems, we will be given the diameter, and you have to make the conscious effort to take your diameter and divide it by 2 to get your radius. Because notice, all of our formulas use a radius. So make sure when you're taking the test that you are always finding the radius when the circle problems come up. Another big hint for the test. And then the third thing from the Chapter 8 toolkit that I want to go over is scale factor ratio. A lot of mistakes on this lately. Scale factor ratio, we've got our scale factor, our linear scale factor, which we call R. But when we're talking about areas, it's R squared. And when we're talking about volumes, it's R cubed. So for example, here's the problem. Since all spheres are similar, a softball and a baseball will be similar and have appropriate scale ratio of 3 to 5. Approximate scale ratio of 3 to 5. If the weight of a baseball is 5 ounces, what is the weight of a softball? Now, a lot of us have been doing proportions for this, and we've been setting them up like this, okay? And that is a good start, but if this is what you try to solve, you are going to get the answer wrong. Weight is a volume issue. Weight is a volume issue, and so if you kind of remember back, we did this with a statue of Benjamin Franklin in class. We have to multiply by R cubed because it's a volume problem. So how do I cube this fraction? pretty simple. You just put a cube on both the top and the bottom. And so what I really want to do is I want to do 3/5 cubed, which is 27 over 125, equals 5 ounces over X ounces. So I get 27X equals 625, and I'll divide that by 27. And so a softball would weigh approximately 23.15 ounces. Okay? So that's a reminder of how to do those types of problems. Be aware. Are we dealing with area? Do I need to square my scale factor? Or am I dealing with volume where I need to cube my scale factor? So read the problems carefully and set up your proportions and solve them that way. Okay? Chapter 9, we started with our solids. Okay, remember that our isometric views, you need to know where the front is, you need to know where the right is. In all map plans, the front is the bottom and the right is on the right. Okay, so this map plan does not match up with this. Those are not the same. This map plan, the map plan for this isometric would look like this. It would be 2, 1, 2, 0, 0, 3, 0, 0, 1. That's what that one would look like. Right? The views, front, right, and top, you might need those when you're dealing with the blocks, volume. And this kind of set up the whole situation for volume and surface area. Area of the base times the height, known as capital H. Okay? Area of the base times the height. And that worked for prisms. We modified that for pyramids. Okay? Surface area, the sum of all the exposed spaces, so you got to count. Like surface area for this one in particular, I would see 1, 2, 3, 4, 5, 6, 7 from the front, so 7 front and back, or 14 I should say. From the right, 1, 2, 3, 4, 5, 6. So 12 from the left and right. And then the top, 1, 2, 3, 4, 5. So 10 from the top and bottom. I'd add all those together, and I get a grand total of 36. The surface area of this particular one. Again, that's just review. I know I'm going a little fast. You can rewatch it if you need to. So here are the things that you should have on your toolkit. I will modify some of these formulas if it'll help. But basically, prism, area of the base times the height. That's our volume. So capital B times H. Surface area, there's no secret to surface area. It's just add up all the areas. There's really no secret to that one. It's to add up all the bases. Take your time on those problems. Show your work. Write everything down so you can find it. Okay? Show your work to yourself. Write things down. Cylinders, on the other hand, are a little nicer because we know what capital B is going to be. For a cylinder, we know this is our circle formula. So for a cylinder, your volume formula is specifically that. And for the surface area, it is specifically this. So it would be 2, oops, that's not right. Silly. Okay. There we go. Okay. So surface area of a cylinder, the area of the bases, r squared pi times 2 plus the height times the circumference. So 2 r pi h. So that would be your surface area of a cylinder. Pyramids, we built off of prisms. So our volume for pyramid was capital B times capital H. It's a prism, but it was divided by 3. It was 3 square pyramids that could fit into the cube. Surface area, again, no secret formula to this one. You just have to find all of the areas of the pyramid. The key to surface area is make sure you are using the slant height, this L. Alright? And if you need to find that, what you might need to do is make a right triangle and help yourself find that slant height. Okay? So find the slant height so that you can have the height and the base of these triangles on the side. Okay, so L would be, this would be my base, and then we would have L right here. That would be the height of that triangle. Cones. Okay, cones a lot like pyramids. Cones a lot like cylinders. We have a specific formula for that. So it would be r squared pi times h divided by 3. So there's your volume of a cone. It's the same as the volume of a cylinder divided by 3. And then surface area of a cone, we went through this kind of extensively on Tuesday. The lateral surface area of a cone, we ended up with RL pi. So we got that in the lateral surface area. That's just the lateral surface area. For a cone, for like a net of a cone, we'd also have a circle here, and we would have r squared pi. So the surface area, total surface area of a cone would be r squared pi plus RL pi. That's how you would find the surface area of a cone. And last but certainly not least, the sphere. We did this one on Wednesday. We got a volume formula. It is 2/3 the volume of a cylinder, or 2 times the volume of a cone. Either way, we get this nice little formula, 4/3 pi r cubed. Some of us we wrote it like this, 4r cubed pi divided by 3. They all work. And the surface area of the sphere, 4r squared pi. Got that one from the lateral surface area of the cylinder. That was in class. So if you want to go back and review any of these from the days of notes, spheres were 11.15. Cones were 11.14. Pyramids were 11.13A and B. If you need to go back and review cylinders, that was in 9.1.2/3. Prisms was 9.1.1/2. So we the prisms and cylinders were anywhere between 9.1.1 and 9.1.3. You can even look at the supplement if you needed to. So that's where all of that is. Again, I apologize, it's a little bit longer, but there's a lot of stuff to cover in this one since you have to go back to chapter 8. But hopefully these hints earlier in the video were helpful. And I just went through the test again this morning to remind myself of what kind of hints you might need. And remember, if you have questions while you're taking the test, ask. Come to the MRC. Shoot us an email. Come ask us next week.